My second video in my module on measures of position of data within a data set. In my last video we talked about how to determine where certain data lie within a data set. Say we had some data set here that was listed in order, all the way out to the nth datum for the data set, but trying to describe where a data value falls within a data set. And so we had discussed the z-score or standard score, which described how many standard deviations above or below average that datum is. In this video we're going to be discussing what we call a percentile, or a percentile, and I want to add this word in here, a percentile rank, which is really what we're doing, okay? So when we talk about percentiles, the first thing is this: it is totally different from a percentage, okay? In terms of what it's describing, in terms of how it describes it, it's somewhat similar in the fact that we say percentiles are measures of position, or position measures used in, say, educational health-related fields, but to indicate the position of an individual within the group, okay? It's just that the group doesn't necessarily have 100 elements, so the percentile scale is, it scales it to seemingly be out of 100 elements. So in terms of how a percentile is similar to a percentage means out of 100. What we're saying here is this data set right here has n data in it. And so what I want to do is say, well, okay, let's say I were to line them all up in order, and I want to know what percentile rank the third datum is in. There may not be 100 data in this data set. But what we can do is we can take where it is in this data set and convert it to a kind of a percentage, and it would give you a relative idea of where it's located. So let's go ahead and define what we mean by percentile in terms of what it's describing, and we'll talk about why interpreting it to be out of 100 would be a benefit. Okay, so we say a percentile tells the reader that the data value in question, so we have a percentile for that data value, is equal to or greater than that percent of the rest of the data values in the data set. So let's say for this data set here I have like 20 data, and I say that this third one in the data set, what percentile is it in? Roughly speaking here, I'm going to say it's in like maybe the 15th percentile, and it's not actually true, but I'm going to say about the 15th percentile, because what I can say is, putting these all in order and going out to the 20th datum in the data set, what I'm saying is that this datum is bigger than 15%, or at least equal to 15% of the rest of the data set right here. So 15% of the data set falls below this right here. And so you can see how, like, if I were using like height data and I say you're in the 99th percentile, it just means that compared to everybody else in your data set, you are taller than 99% of them, or at least just as tall as them as well. Or we could say, let's say blood pressure, blood pressure. Maybe I'm in the 10th percentile, which means that my blood pressure compared to everybody else's blood pressure is only greater than or equal to 10% of the rest of my peers in that data set. So that is what a percentile is describing. So what we're going to do in this video is we're going to define, of course, this percentile rank and interpret it, but I also want to show how you calculate this for, say, grouped data, and then construct what we call a percentile graph, which, by the way, is heavily related to what we called in the past an ogive, or a cumulative frequency graph. So we say that the frequency distribution for the systolic blood pressure readings in millimeters of mercury, so mm of this Hg here, of 200 randomly selected college students is shown here. So we have our class boundaries, so our lowest class and the highest class, and you can see that this is not normally distributed perfectly, but approximately normally distributed. We have a big bunch of people here somewhere in the middle, and as we deviate away from the middle, it starts to go down in frequency. But in terms of what we want to do, we want to find the percentile ranks first of all for each class, and then make a percentile graph. So first things first, when you talk about a percentile graph, we're talking about really a kind of a graph like an ogive, where we take into account cumulative frequency. So recall that we have 24 people from 89.5 all the way up to 104.5 millimeters of mercury. 24 people fell within that. So we'd say, well, how many people have we counted by the time we've gotten up to 104.5 millimeters of mercury? We've counted 24. But when you go to this next class, we say, okay, really, what's the cumulative frequency by the time we've gotten up to 119.5 millimeters of mercury? Up until here, if we were to count everybody below it, we'd say not just the 64 in this class, but the 64 plus the 24 we've already counted. So if I add 64 onto this, I get 88. Okay. If we were to take this 88 and say, okay, so now by the time I've gotten up to the end of this class, 134.5 millimeters of mercury, how many total people have we counted? We've counted all of these people right here. So really this 88 plus 72 more, so 160, and then we'll add on this 26 here, we get 186, add on 12, we get 198, okay, and then last but not least, if we add on this last 4 here, actually that's a typo, let's go ahead and change this to a 2, we'll make this an even 200, okay. So 2, we'll say that not many people have systolic blood pressures up here, they're, you know, not in very good shape if that's the case, so it's probably not very frequent. Alright, so looking at these, we want to find a cumulative percent. So in terms of what we're doing is, instead of making an ogive, which is what we are going to do, I'm going to go ahead and draw in my X and Y axes here, where we're going to put, you know, blood pressures down here, blood pressures. This is our X value data, or independent variable here, and we say that these are class boundaries, but I do want to label this in millimeters of mercury. And we'll put our, you know, X value data in here according to our class boundaries, but instead of putting frequencies on this axis, we would want to put cumulative frequency. Now here's the only difference between cumulative frequency and cumulative percent. The idea here is this. We said percentile is telling me, yeah, you know, kind of where I rank compared to the rest of my peers in the group, but percentile means out of 100. And what I was told going into this was that this group had 200 total elements in it. So if I were making an ogive, I would have to go up to 200 total. I'd have to go up to 200 total. But what I want to do is I want to change this to a percentile, which makes this a little bit easier to understand, because what it does instead is it says, let's convert this to automatically being out of 100, or change it to a percentage. Okay, so what we're going to do is this. I'm going to write the formula first, but to find the cumulative percent, we are going to take the cumulative frequency, CF here. I'll write a little formula here. Take the cumulative frequency, and we are going to divide it by the total number of data. So for instance, if I get my calculator out here, we say 24 out of 200 total people, what percentile rank would they be in? We'll take our 24 divided by 200, and really what we're saying is we're in the 12th percentile, or somebody that has a blood pressure of 104.5 should have a blood pressure that is bigger than, or at least the same as, 12% of the rest of the people below them in the data set. So we're going to write this out here. We say 0.12. Let's go ahead and find the rest of these values. So I'm going to pull the calculator out back out here, and we say 88 divided by 200. We're just going to do this for all of our data here. So 88 divided by 200 is 0.44. So again, we'd say that somebody who has a blood pressure of 119.5 millimeters of mercury has a blood pressure that is greater than or the same as 44% of the rest of the people in the data set, or there's 44% of the rest of the data set is below their systolic blood pressure. So 160, you know, 160 divided by 200, this one's a little bit easier to do in our heads. We say reducing that becomes 80 out of 100, 80 out of 100. So this is going to be 0.80, so that's the 80th percentile. 186 divided by 200, which is, I should write that out, but I'm noticing here that I don't have a lot of room, divided by 200. We get a 93rd percentile here, so we say 0.93. And we say 198 divided by 200, well I think that's about 99th percentile, but 198 divided by 200 is the 99th percentile. So like we're saying by the time you get to 164.5 millimeters of mercury, your blood pressure, if that's yours, is greater than 99% of the rest of the people in the data set. And then by the time you get to 179.5, you know, we're taking 200 divided by 200, which is 1.00. So a few comments I want to make on this one. Should always be the 100th percentile. And the reason why is because this last data value, it was the end of the data set, you've counted everybody up. So this blood pressure should be bigger than or the same as 100% of the rest of the people in the data set, because nobody was greater than that. And when you label the y-axis here, the nice thing about percentile graphs is you don't have to think about scale very often. We're just going to make this top one always 1.00, and we're going to call this a percentile. Okay, cool. So I'm going to split this in half. As a matter of fact, I'll call this half. And I like to split those halves in half. We'll call this the 25th percentile, just kind of a benchmark here, and the 75th percentile. And when we make this graph, I'm going to go ahead and drop in my values down here. We're just going to drop in our boundaries. So we say 89.5 millimeters of mercury. This would be 104.5. We go to the next one is 119.5. You have to bear with me here. This is 134.5, 149.5. 164.5. We got one more to go. 164.5, and this last 179.5, 179.5. And what we're going to do is we're just going to match up and graph all of these cumulative percentages above these dots. So first things first, 89.5 millimeters of mercury. Because this occurs as the lower limit or the lower boundary of the lowest class, we would say that the cumulative frequency here technically is 0. You haven't counted anybody yet because you're at the beginning of the very first class. So very important that this starts as being the 0th percentile, but now we're just going to go right across the board here. So the 12th percentile would be a little bit less than half the way to 25 here. So we say about 12th percentile would be about, you know, right there-ish. We say, okay, so now our next class, 44th percentile, we say 119.5. By the time we get to the end of this is about the 44th percentile. It'd be about right here. I say, you know, 44th percentile be about right there. And then we say, okay, well, how about the next one is the 80th percentile. So by the time we get to, you know, here, we've gotten past 80% of the data right here. Okay. And then we say, okay, well, now we're dwindling down. There's not so many people out here on the edge. So we say the 93rd percentile, go a little bit faster here. 93rd percentile is almost to 100. And then we had the 99th percentile. And assuming that the 100th percentile is about right there, we say the 99th percentile would be about right below 100, and then the 100th percentile would be here. So again, with ogives, remember we want to connect the dots on these, but this is my cumulative frequency graph, but when we've changed everything to a percentile. So in terms of what I can use this graph to do, as a matter of fact, we can say, well, here's what it looks like, but maybe I have a question like this. If I'm looking at this, I say, well, hey, you know, my blood pressure, you know, just my systolic is, you know, usually not that bad. I say 128 is usually where it lies. I'd say, what percentile am I in? Percentile. And the thing is, I can read this graph by saying, well, 128 millimeters of mercury. Let's go down here and find 128. Now, 128 might be, you know, here's about 120, here's 135. 128 might be somewhere right around here. And so when I say, what percentile am I in? The reason why we connect these dots is because we kind of go over here and we say, all right, well, I am in the, you know, if I had to interpret this, maybe like the 60th-ish percentile, which means my blood pressure, systolic blood pressure, is actually greater than 60% of the rest of the people in the data set. Okay, so maybe I should be worried, maybe not, pre-hypertensive, I don't know. But also this, I can ask this question, I say, okay, well, what would my blood pressure have to be then for me to be in the 50th percentile? You know, maybe that's where I want to be. I want to get my blood pressure in the right spot. So we say 50th percentile. Now I'm going to go up here. I'm going to say 50th percentile is right here. And I know that, you know, it's got to be right around here because I know that at 119.5, I already observed this as being the 44th percentile. So it's got to be bigger than 119.5. And again, we could just read this graph down. We could say, well, my blood pressure must be around like 120, maybe 124 millimeters of mercury. So this is what a percentile is, how you construct a percentile rank graph, and how you would necessarily use this graph to read it. Okay, cheers.